footprint or the risk reduction capabilities of your organization. And the globally harmonized system is exactly that, a system or a process for and labeling chemicals. Standardized approach that's been adopted throughout much of the world and is geared towards defining the health and physical and environmental hazards of materials, more importantly classifying those hazards according to very specific rules and according to very specific methodologies, and then finally communicating what those chemical hazards are in the workplace and beyond downstream to those people who either have to use or process the chemicals or materials that chemicals are found in. The term harmonized is a little bit of a misnomer. What we found is that throughout the world, the harmonization of hazardification from a big picture has occurred, but there are very specific nuances that have changed in several of the adoptions of GHS. Now, here in the U.S., which is what we're going to focus on today, we had the HAZCOM standard, HAZCOM 1994, which has now been updated to HAZCOM 2012. The OSHA regulation that's impacted by this is OSHA 1910-1200. Has been around for quite a long time. Every organization out there that has chemicals in the workplace is impacted by this, whether you have chemicals in the workplace or you distribute materials that require a material safety data sheet or labeling, or your employees utilize chemicals in their daily activities, even things like housekeeping or maintenance. You will be impacted by the adoption by OSHA of GHS into our hazard communication standard. This has been a long time coming. It's been about 20 years in the making. And what's happened is by updating and adopting GHS into our OSHA 1910-1200 standard, we have now adopted from a performance-based standard to a very structured standard that requires the conveyance of specific formats and content on chemical hazard via the SDS, or the formerly known as MSDS, and labels. In addition to that, the labels have to provide instructions on how to handle it, how to dispose of it, for example, or what PPE to use. And so this adoption of the globally harmonized system into our US-based HAZCOM regulation has created some very significant needs and changes within all organizations. When we talk about the adoption of GHS here in the US, there are really 5 significant areas of change. And what I have to do is go through an overview of GHS. Everybody's probably heard the terminology, but I want to dig in a little bit on an overview of what these changes are before we get into the actual data and what those changes mean, and then more importantly, how you can use that information and the changes to our system to help reduce risk in your workplace. So those 5 areas that are significant were the hazard classifications, as I mentioned earlier. The actual rules and methodology for determining what the hazards are of the materials have all changed. It used to be very simple. There was a 1% or 0.1% cutoff on hazards. Now there's a whole set of rules for every health or physical hazard. More importantly, that means that every safety data sheet is now going to be modified. So they no longer even called MSDSs. So all of those old yellow binders that people see, or if they walk into a retail place and they see call 1-800 so-and-so for an MSDS, are outdated. The new terminology is SDS. More importantly, the format and content of those have changed. The third significant area is labeling. And this goes for both your products being labeled that have health and physical hazards, as well as workplace labeling for materials that may come in a larger container that get broken down into smaller containers. The last 2 elements are a direct result of the first 3 changes. Communication and training have always been a part of hazard communication, the regulation, and now as a result of these classification, SDS, and labeling changes, we have to communicate that differently, and we have to train our employees on what those changes are. There have been some very specific timelines, and most people are aware of those. The very first timeline and deadline that's actually passed was December 1st of last year for training all employees on hazard communication related to the modifications by GHS. You notice we have a question mark by the completed. The reason for that is that in reality, it's an ongoing requirement. So obviously, every employee needed to be trained by December 1st of last year, but more importantly, as you get new employees in or as something changes in your workplace, that training has to continue. June 1st of next year is the next significant deadline. At that point, all chemical manufacturers have to comply with the final rule, which means that every material safety data sheet has to be updated and modified to meet the new standards. That's pretty significant in the simple fact that that means that by law the manufacturers have to send those modified SDSs to all of their clients who are using those documents. The second deadline coming up is December 1st of next year, and at that point chemical distributors and manufacturers should all be shipping products that have GHS compliant labels. And then the June 1st of 2016, a little over 2 years away, employers and distributors have to update the workplace HazCom program and train employees on newly identified hazards, i.e. the fact that some of these classifications have changed in their products. They're now aware of the change as a result of everything getting through the system from a SDS and labeling requirement, and now training has to be modified and programs updated. So that significant change for those deadlines takes us over to the very next step, and what I consider the one that's probably most impactful to everyone. Over the years, we've all seen a material safety data sheet, order one of the yellow binders that may have dust-colored or rolled up faxes or faded faxes or handwritten notes that worked as a material safety data sheet. Well, that is all changed, and as a result of this, and a result of adoption of GHS, every material safety data sheet is now going to be called a safety data sheet. In addition to that, there's a required format. There are 16 sections, where Section 2 is the hazard identification information. As you can see by the PowerPoint, you'll note that the hazard information, pictograms, signal words, the precautionary statements, for example, keep away from heat, sparks, or flames, are all generally found on the first page or two of a material safety data sheet, or soon to be called safety data sheet. In addition to that, not only is the format changed, but this reclassification, this set of rules that we have to follow to decide what the hazards are listed and communicated to the people using the material will occur. So all health and environmental and physical hazards are going to be reassessed. There is a building block approach to this. It's very complex and complicated. And one of the things that's important to note for any organization, if you have a product that requires a material safety data sheet, it's very important your organization, you find out who's responsible for writing that SDS, going to them, ensuring that they are aware of the changes, and ensuring that they have a plan in place to get that safety data sheet updated to the new standard. There's risk to your company if it's not done, because you will be putting your company, one, out of compliance, and two, your customers at a disadvantage, which can be a marketing risk as well. In addition to that, there is a bandwidth issue in the authoring industry. Those people who have the expertise to write material safety data sheets are very limited, and as a result of these very complex rule changes, there aren't that many people out there who can write an adequate safety data sheet. So it's imperative that have that situation in your organization, that you talk to your resource and either find a third party who can author the document for you, ensure that the person in your organization gets a quick training to create that document in a compliant format. The second issue associated with this is the simple fact that those of you who have SDS binders, MSDS binders, or hazard communication programs are going to have to come to the realization that every document is going to be rehandled and updated and submitted to you, which means you may get those updates over and over as manufacturers reauthor their documents, which means additional effort on the end of your safety professional or HR department or environmental person who is handling material safety data sheets. So it's a big churn. OSHA estimates that there are 800,000 material safety data sheets out there. In our business, we actually believe there are about 1.5 million, just because of the fact that the resulting of the rules means that material safety data sheets may be broken into more than one, where you could have multiple materials on a safety data sheet. In the past, you may have more than one safety data sheet for the same 3 or 4 products as a result of the classifications. So once we get past the safety data sheet, the next significant change are the GHS labels. And so there are very specific and required elements of a GHS compliant label. You'll notice I have them numbered on the screen with the product identifier, signal word, and H&B statements, supplier identification, and pictograms all being found and noted. It is important to note that the signal words, H&P statements, and material name and pictograms all be co-located together on the label. Now, one of the things that's a question that comes up all of the time regarding labels are, can I use my existing NFPA Diamond or HMIS labeling for workplace labels? In the past, those have been accepted by OSHA, and in reality, going forward, they can also be accepted by OSHA for workplace labeling. However, there is a gotcha. First of all, the NFPA Diamond and HMIS label formats don't provide all the information necessary to meet a true hazard communication label. More importantly, if there's an inconsistency between what's on the NFP or HMIS method of creating a label and that of the GHS label, which I've just shown you, i.e. the hazards are different, you're at risk, and you have to have both pieces of information available to your employees. The next important part to note is that every material that gets shipped by a manufacturer will be required to have a GHS label if it is a hazardous material, as defined by the requirement for an MSDS. So the products are going to come in with a GHS label. It makes sense to have adopt the GHS labeling for workplace use as well. But it is important to note that if you have an internal labeling system of your own, you can use that. You just have to ensure that through training and through consistency, there's no conflict between the GHS labels found on the material or the information found on the SDS and the label that your organization applies. If you ask me for our recommendation, we would always suggest that you go ahead and adopt the GHS label going forward, because you're going to have to ensure that your employees know that standard anyways. Another myth out there on labeling is that you have to have red framed in-house labels for workplace labeling. That's actually not true. There's an OSHA brief out there that says you can use a black and white printer to create the black diamond frame for labeling. Now, one of the gotchas that we're seeing is that not all SDSs are updated. As I mentioned earlier, material safety data sheets are all being converted, and in our business, we see that less than 15% of all the material safety data sheets have been updated to the new GHS format. Now, we're less than a year away from the final deadline for that to be updated. So we anticipate a pretty significant influx, but again, there's the bandwidth issue for qualified authors. And as a result of that, we know that some manufacturers won't make it, and without the GHS information found on the SDS, you cannot create a workplace label or a product label that meets the GHS requirements. So labeling, again, always raises lots of questions, and we may have some along the way. If you guys do, feel free to add those into the question box, the chat box, and I'll be glad to answer those at the end of the presentation. But from a labeling perspective, we get asked a few questions, and I thought I would throw this into a slide for everyone. First of all, who's responsible for updating labels on shipped containers? Well, that's the manufacturer or the distributor. So if the product requires a GHS label, the manufacturer must put one on it, or the distributor. The same thing for updating the product safety data sheets. That's the manufacturer distributor. So if you put your name on the MSDS, or soon to be SDS, then you're responsible for supplying that downstream to your customers. And you must do that with each first-time purchase or anytime there's a significant change to the SDS. As far as maintaining labels on the containers or tanks or totes or drums, well, that's the employer. So if a material, a drum or tank comes into your workplace, has a label on it, and then through you moving it or a spill or it gets worn off, you have to have the ability as the employer to replace that label for that container. Which goes to the next bullet point, maintaining them in a legible format and ensuring that pertinent information doesn't get defaced. Again, that's employer's responsibility, as well as communicating newly identified hazards that aren't found on the label. So, for example, if the label comes in as incorrect and you see the STS and it does have a hazard that wasn't listed, then that has to be communicated to the employees. And then finally, the ability to create your own workplace labels if you bring something in a large container and put it into smaller containers. For example, a drum or tote that gets put into small 5-gallon pails or squeeze bottles requires the employer to be able to create a label for that material container. So the last two elements that I mentioned of the significant changes as we go through what the overview of GHS is, we're community training. And for the communication training part, we roll this all into one. What is it that you need to know? What's your timeline for transition, i.e., obviously the December 1st date is come and gone, the June 1st date is coming up. What are the changes required to update my current HAZCOM program? Am I aware of what materials are GHS compliant and which aren't in my facility? More importantly, what do the employees need to know when you train them or once they're trained? How do they access the hazard information, the MSDS and the labels? What are the changes to both the STS and the label, the pictogram definitions, the signal word definitions, those hazard classification categories, and the H&P statements, the hazard statements and precautionary statements? Now I'm going to talk about, in the next section, the actual data itself. And so some of the terminology I've used may or may not make sense, but we're going to try to tie this all together and define what the terms are and talk about what those critical hazard statements that may be found out there on an MSDS or on a label, so that if you see that, your employees can be made aware of that hazard. So as we get through the overview of the GHS adoption and what the changes mean, feel free to throw questions in and we'll answer those at the end. And we're going to go ahead and move forward into the second part of this presentation, which is talking about the data and the definition. So we built the overview. We're going to build what the terminology and how it's used and what it means. And then we're going to talk about how it's all derived, and then that'll take us to the final part of our presentation, which is using this information to reduce risk and understanding how you may take advantage of it. So the simple fact is we use the term GHS pictograms. There are 9 of those. Some look familiar, some don't. Some you'll see in DOT labels and some you won't. OSHA has adopted only 8 of those, but you would be best suited to go ahead and educate employees on the 9th, which is the environmental pictogram. Pictograms on labels, with the exception of workplace labels, and on SDSs will have the red background with the black symbol, and the actual definition may or may not be associated with the pictogram. So you'll notice that in each of these you'll see the definition or the term, the flame, the exploding bomb, flame over circle, which means oxidizers. Exclamation mark is generally one that you're more likely to see, which are acute toxicity or irritants. The carcinogenic or health hazard, which is more of a longer-term hazard, longer-term exposure hazard, you won't see as likely. You'll see flammability quite often. These pictograms are the key identifier on labels and on products for your employees to understand the initial hazards. We also use the term signal word. The signal word is danger or warning. There aren't but 2. In the past, you may have seen caution. I had a consultant once say that OSHA threw caution to the wind when they adopted GHS. It was actually fairly funny in the right group setting. Probably doesn't make a lot of sense on this webinar, but I thought I'd throw it out there. Danger is the most severe, and the absence of a signal word does not mean that there is no hazard. It just means it's not a severe hazard of any form or fashion. The hazard statement is a statement assigned to the hazard class and category that describes the nature and even the degree of hazard. Precautionary statements are those that describe the measures taken to minimize or prevent adverse effects from exposure or improper handling. So you'll see things like prevention, response, storage, and disposal phrases, and all of those must appear on the label. which goes back to that labeling discussion we had earlier. One of the gotchas that we see out there is that in the past it was very easy to look at a diamond, pick up the color and the number, where 1 being the least severe and 4 being the most severe gave your employees an indicator of the hazard. Now there are categories with 1 being the most hazardous and 5 being the least hazardous. Those don't appear on labels, but they will appear on SDSs and potentially on the products themselves as necessary. So there is an opportunity for confusion, so it's very important that the training element of the changes be significantly reviewed and adopted by the employees that are exposed to chemicals. So we use the term classification from the very beginning of this presentation, and what that means is determining the hazard class and where appropriate the severity. This is what I was talking about when I mentioned that there's a category or classification of a 1 or 2 or 3 or 4 or 5. 1 being the most hazardous, so you'd see in the past maybe on an SDS or label something that said corrosive. Now you're going to find out how corrosive it is. A skin corrosion category 1A means it's very, very corrosive and probably requires a very specific personal protective equipment, a specific type of glove to handle it. Whereas in the past you might see irritant. Now you'll see it's skin irritant or eye irritant. So there's better information out there for understanding what the risk is and what the employee may be exposed to if they have a spill, for example. There are 2 types: health classifications, health hazards, and physical hazard classifications. OSHA did adopt some new health and physical hazards. You'll see the blue at the bottom of the screen. Asphyxiants, hazards not otherwise classified, and over on the physical classification, pyrophoric gas and combustible dust. There's a lot of talk about combustible dust. Now there is a physical hazard classification and a hazard statement for that. So by rule now it has to be included if there's a known explosive or combustible dust issue. You'll see the classification, the category out to the right as well, categories 1 and 2 or 1, 2, 3, and 4. Those all denote the severity of the hazard. And what this means is that a material could have multiple health or physical hazard classifications with the various categories for each of those hazard category being listed on the SDS. I did want to give you guys a takeaway from this because a lot of the terminology gets confusing, but when it's all said and done, we're still trying to understand how hazardous a chemical is, and more importantly, what's this information mean to my employee or to the workplace or to my organization when I'm shipping it or handling it or disposing of it. So I wanted to give you a list of the most hazardous health statements for all health hazards along with the category. So for example, if you see a H3O4 may be fatal, swallowed and enters airways, that's an aspiration hazard, category 1. That phrase alone will tell you that it's very, very significant hazard, and your employees should be very careful if they're around it. Same thing for may cause an allergic skin reaction, sensitization, skin irritation, category 1A, 1, or 1B. All of those denote, if you see that statement on there, that this is a very hazardous material. So you won't see this exact phrase. You may see causes skin irritation for something that causes a mild allergy, but when you see may cause an allergic skin reaction, that statement tells you that it is something that did this hazards. Flammable heating may cause an explosion, can fire spontaneously if exposed to air. May be corrosive to metals. Category 1 is probably a very, very strong acid and would also have a potential health hazard associated with it. Finally, I'll give you an idea of how and the rules are created, and more importantly, how those classifications arrive at, so we understand how we're going to use this information to be a better organization from a risk perspective. So what happens is when you're creating a document, you have some information on the hazard set or the properties of it. In this example, flash point, we're looking at trying to understand if it's flammable or not. So if we see that the flash point's greater than 73.4 Fahrenheit or less than 140 degrees Fahrenheit, that tells us by rule it's a category 3 flammable liquid. So when we realize it's a category 3 flammable liquid, the person writing the document goes to the next appendices in the rule and says, oh, category 3, that means the signal word we send the label is warning. We add the hazard statement, flammable liquid and vapor, excuse me, And we add the pictogram, the flame pictogram, to both the label and the SDS. In addition, these precautionary statements that apply must be used on the label and on the SDS. There are a lot of precautionary statements. This also means that this is only one hazard. It's possible that there could be many hazards for this material. It could be an irritant as well as a flammable. It could be some type of other chronic hazard. So when it's all said and done, the process for creating and understanding the classification of a material is pretty complex. The great news about this is that because there is a consistent set of rules, because there's a consistent message and methodology that people have to follow, no longer are you going to get an SDS that only says, you know, consult your local, state, and federal authorities, or no data available. You're going to have information on that material safety data sheet, on that label, that is consistent across anybody who creates or manufactures that chemical, and is able to be used to understand risk. Which takes us to the final portion of our presentation, understanding and reducing risk. There's always a process to this, and we always recommend the first thing that a company or organization do is just define the level of risk you're not going to allow into the workplace, or that you have to manage stringently. Now, sometimes that's pretty tough to do, to create a baseline. One of the benefits to having a consistent hazard classification is that from a chemical management perspective anyways, you can very easily set that baseline and define that level of risk. More importantly, ensure you have an effective chemical approval process in place to know and manage which chemicals are being brought into the workplace. And then finally, leverage that data, the fact that SDSs are going to be updated to not only look at new chemicals coming into the facility, but to look at and review existing chemicals in the workplace and find areas to reduce hazards or get rid of chemicals that are more hazardous and more likely result in a spill, which can result in cost for disposal, or even more significantly, an employee being exposed to a chemical that causes them physical or harm. So when trying to get to that baseline and determine what that level of unacceptable risk is, we suggest using the term risk matrix. And the great news about GHS adoption is that you could create a risk matrix, which is a combination of the pictograms that you see on the hazards and the chemicals in your workplace or your products, the signal words, you know, anything that has danger, for example, should absolutely be reviewed and the decision made by one on whether it is allowed and how it's used, if it is allowed in the workplace. What GHS classifications and categories are severe enough that you don't want them in the workplace, and that's where that level of severity comes into play. Again, all this information is going to be available right on the first page or two of the material safety data sheet, and many systems out there allow you to pull that information off the safety data sheet to the system and run reports and queries to make quick decisions on those materials. So once you've defined your level of unacceptable risk, what your baseline is for your risk matrix, then you decide what your actions are, right? Because business is business, and you can't simply just say, I can't use this chemical because it's hazardous. It may be that you find a replacement, or it may be that you have specific personal protective equipment that's necessary for handling or using it, that you provide specific training, including how to handle it or store it, and what the response is if there is a spill or an exposure, i.e. is there an eyewash station in the area? Is there, and if so, is it water-based? If it's a water reactive chemical, we don't want to use a water-based eyewash station. So again, we go back to the fact is that because of the adoption of GHS, all this information is going to be updated, it's going to be current, it's going to be consistent, and there's going to be a set of rules that can be used to develop that risk matrix. So one of the things that we talked about was chemical approval process. So you build your risk matrix, you set your baseline, you understand what happens if you do have to exceed that baseline on risk. But more importantly, how do I then determine what chemicals are coming in? So there are certain elements that create an effective chemical approval process. One, are the appropriate personnel in the review cycle? Is it something that's trackable? Is it something I can go back and say, who reviewed it? What were the hazards that I reviewed? What was the decision I made? More importantly, can I modify this as environmental regulations change or safety regulations change or people are on vacation, for example? And then finally, the number one successful element of a chemical approval process is that it's a closed loop. If somebody takes the time to fill out a form or create a document or fill out an online request, do they get notification back that it's been approved or declined? If they don't, inevitably they'll quit filling those out. They'll start taking chemicals that come into the workplace from the salesperson that drops it off or from a quick run out to the local hardware store for some type of maintenance agreement. More importantly, once you've created an effective chemical approval process, can you go beyond that? Can you include your risk matrix in your approval process, and i.e., what's the baseline? And when I bring in a new material, get the SDS ahead of time before the chemical ever shows up and review it against my risk matrix to understand if there is an opportunity to find a replacement, or do I have to have special handling or storage or training requirements for the use of that chemical? So, you know, we've talked about applying your risk matrix to new chemicals coming in, understanding what that is. More importantly, going forward, a lot of companies are trying to reduce costs and risk as an organization. So now that you have a baseline, you could go back and apply that to your existing chemicals already in use in the facility, already in use at the maintenance department or in the process line or in the shipping department or in housekeeping, and determine if those are a potential cost structure issue related to exposures or risk. You can even incorporate KPIs related to risk in your overall compliance program. A lot of companies now use the fact that they are a good product steward and they're a good, have a great safety record, and that their employees are thought of in the community as part of their mission statement to not have releases or exposures or spills, become key performance indicators and are often used for marketing and differentiating yourself from your competitor. So by having this consistent message in this risk matrix, you can make a determination that I want to reduce certain hazards by 5% over the course of the year. And then start using the information that's the consistent message out there to understand where I can remove that. When it's all said and done, I firmly believe that the adoption of GHS and the classification rules and methodology will allow everyone to take advantage of this consistent, this standardized format, this consistent message, which will allow everyone to implement a world-class chemical hazard footprint reduction plan. In other words, reduced risk. So I always like to wrap up with kind of an overview of the process. I'm a very process-driven person. I think that getting from point A to point B is great, and if you have a map on how to get there, knowing where you want to go is the first step, and then having the steps that you take along the way defined so that you can see if you're and measure those steps, make sure you're meeting those goals, will allow you to be more successful in the end. So we talked about a chemical approval process, but I didn't really mention one of the things to do because of the updating of material safety data sheets and labeling is to understand which chemicals are in a workplace. The best way to do that is to perform an initial chemical inventory. Get rid of those chemicals that you don't use in day-to-day operations. Get rid of the things that are rusted to the shelf, know where they're located, and understand what the hazards are associated with those materials, and then train on those. By reducing those materials and knowing what chemicals are where in the workplace, you can start with a great baseline. Then initiate that chemical approval process. So from the time you finish your chemical inventory to the time you start your approval process, a gap will grow because people will bring materials in. So have your approval process ready to roll out upon completion of a physical chemical inventory, and make sure that that approval process has the right people in it, that it's flexible enough to deal with people being on vacation or changing jobs or changing operations, and finally that it's that closed loop, that it gets a note or message or email back to the person who made the request. Then utilize technology to do an inventory and reconcile with what's in your chemical inventory at least every 2 years. Most people will look at it once a year. You may even use light work duty, people who have light work duty capabilities to do that inventory. And then reconcile materials and get rid of, again, archive those materials that are no longer in use. It's an important note that nothing's changed in the requirement for maintaining chemical hazard data. By law, you must maintain chemical hazard data for 30 years plus time of employment. So the best way to do that is to save an electronic file of every material safety data sheet, or SDS, associated with the chemicals in your workplace. The last step for this chemical management roadmap is to leverage data from your database. We always suggest using technology where you can. So because of this consistent message, because of the hazard classification process, there is an opportunity to have more accurate reporting, to understand the hazards in the workplace and to reduce that chemical hazard footprint, to create a risk assessment or risk matrix baseline, and then use that for profiling the hazards for chemicals coming in and going forward. And finally, that chemical management database of the information that's now consistent can be used for supporting other ISO standards like 18001 or 14001. So when it's all said and done, I firmly believe that this opportunity that we've been given, there's a lot of what I'll call short-term pain for long-term gain. And this short-term gain for long-term pain is going to give us the opportunity to use a consistent information, consistent hazard classification, consistent labeling, and consistent SDS creation processes to have the ability to reduce our training requirements, to reduce exposures by employees to hazards in the workplace, and to create a safer, less expensive workplace when it's related to chemical hazard risk. And with that, I'll wrap up the webinar and be glad to answer any questions that we've had along the way. We're at about 40 minutes into the webinar now, so hopefully this last 5 minutes or so we'll be able to, if we have any questions that have come over, Carly or someone else, if you'd be able to tell me what those are or show those to me, I'd be glad to do my best to answer any questions.
Sure. Yeah, thank you, Scott. Definitely a very informative presentation that makes sense for all. So yeah, like Scott said, he'll now answer any questions that you have. You can type those into the webinar toolbar here. And Scott's information is up on the screen as well. Scott, they can email you or feel free to give you a call if they think of anything after the fact as well, correct?
Absolutely. You know, our goal is to really educate everybody on what's going on and to offer some ideas wherever possible on how they may or may not be impacted or how they can be helped. So feel free to email or call at any time, and we'll do our best to answer questions and support along the way.
Okay, sounds good. You must have explained things thoroughly because I don't have any questions right now. So
well, that or we put them to sleep, which it's not a real sexy topic, but it's very pertinent to the industry today.
Exactly, and to that point, we will have we are recording the webinar, and so I know that there's a lot of information and dates and that kind of thing, and so we will have it on CAPSA's YouTube channel. We'll have it on the website. Scott, you know, you can post it wherever you'd like. And we'll make that available probably early next week, so attendees can expect an email from CAPSA with that webinar recording. Like I mentioned at the beginning of the webinar, you will receive a survey here in about 1 hour. At the end of the survey, there is a link to be able to download Scott's slides, so you can have both the webinar recording and the presentation slides as well to be able to go back and reference. So Scott, I really want to thank you for your time today. I appreciate you being with us and appreciate everyone else for being on the webinar with us. We look forward to having you join our next e-training webinar. We will have one September 5th. More details of those of that presentation will be coming out, so stay tuned on CAPSA's website. And Scott, thank you so much for your time.
Glad to do it. Thanks, everyone, for sitting in. Have a great day.
You too. Bye-bye.